What is that I have to calculate? Amplitude, frequency, time period. Why millimeter? Displacement is in millimeter, so amplitude is 0.3 millimeter. Maximum acceleration of a particle executing simple harmonic motion. On comparison, amplitude is 0.2 meter, omega is 50 pi. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. As we have completed our discussion on the theory sessions, here we start working out the numericals, where my first session of numericals is from the chapter Oscillations. Hope you have gone through the sessions. Hope you have revised the chapter, familiar with the expressions. Only then solving numericals can become pretty easy. The first problem: a body executes simple harmonic motion along the y-axis. So there is a body which is executing simple harmonic motion along the y-axis. Its displacement varies according to the equation y equals 0.5 sine 100 pi t. So the displacement of the particle along the y-axis happens according to the equation y equals 0.5 sine 100 pi t, where y, the displacement, is in meter and t is in seconds. I have to calculate its amplitude, period, and frequency. So very simple. The given equation is y equals 0.5 sine 100 pi t. So if I observe, the given equation is of the form y equals 0.5 sine 100 pi t. What is that I have to calculate? Amplitude, frequency, time period. How do I do this now? I will compare my given expression or given equation with a standard equation, where the standard equation says y equals a sine omega t. So I write the standard equation for displacement. Y equals a sine omega t. Now, on comparison, I'm comparing the given equation with the standard equation. See, it is very simple. In place of amplitude, I have 0.5. Just compare. 1 mark is evident. So, amplitude is 0.5 meter. Any difficulty doing this? Just comparison. Compare omega. In place of omega, I have 100 pi. So, omega is equal to 100 pi. Anywhere can I introduce frequency here? Good. Omega is 2 pi f. So 2 pi f is 100 pi. Pi and pi gets cancelled. Frequency is 50 hertz. Known frequency. How will I calculate time? So C T is 1 by f. So this is 1 by 50 seconds. See, I've just compared the given equation with the standard equation, and just on comparison, I have arrived at the given terms. The next one, again the displacement of the particle executing simple harmonic motion. The displacement of the particle executing simple harmonic motion is y equals 0.3 sine 300t plus 0.25, where y is in millimeters. Be careful, y is in millimeters. Calculate its amplitude, frequency, angular frequency, and initial phase. What am I calculating now? Amplitude, frequency, angular frequency, and initial phase. As again, what is the given equation? Y is 0.3 sine 0.3 sine 300t plus 0.25. So now the given equation is of the form y equals 0.3 sine 300t plus 0.25. Again, compare it with the standard equation. A sine omega t. Now plus there is an additional factor, what I call as phi, which is the phase. See, plus phi with there. There is an additional quantity, plus 0.25, plus phi. That is what is called as the phase. Now compare these two again. Amplitude is 0.3 millimeters. Why millimeter? Displacement is in millimeter. So amplitude is 0.3 millimeter. Omega, directly angular frequency is 300 radian per second. Direct comparison, no calculations at all. Now, see, so 2 pi f is 300. F is 300 by 2 pi. Nearly this is 6. 300 by 6. This is nearly 48 hertz. And the most important thing, initial phase. Given all these things, how will I find out initial phase? Again, nothing to do here. Substitute for phi. That itself is the phase. So 0.25 radian. See again, just comparing with the standard equation, I have arrived at the answers. The next one, students. Maximum velocity. So we have the maximum velocity of a particle executing simple harmonic motion, which is 15.7 meter per second. So maximum velocity is A times omega. We have seen in the chapter where we have written expressions for maximum velocity, maximum acceleration of a particle executing simple harmonic motion. So maximum velocity of a particle executing simple harmonic motion is 15.7 meter per second. And the maximum acceleration, so A max is A square omega, which is 2465 meter per second square. I have to calculate the frequency and amplitude of the simple harmonic motion. So maximum acceleration, which is A omega square. Maximum velocity, which is A omega. Now, first I will take the ratio of maximum acceleration to maximum velocity. Maximum acceleration to maximum velocity. A omega square divided by A omega, 2465 divided by 15.7, which means A gets cancelled, 1 omega gets cancelled, so omega is 157 radian per second. So I have calculated omega, which is 157 radian per second. Am I in a position to calculate frequency now? Yes. So omega is 2 pi f. So 2 pi f is 157. So f is 157 by 2 pi. So 157 by 2 pi is 25 hertz. So very simple. I have calculated frequency using this concept. Now what about amplitude? Now for amplitude, velocity has to be maximum. So V square max is A square omega square. V is A omega. V square. A square omega square. I write this as A omega square. Now what is A omega square? Maximum acceleration. So this is A max. Can I not calculate the amplitude now? So amplitude is V square max by A max. Maximum velocity was given to be 15.7. Square that. So this turns out to be 0.1 meter. So amplitude is 0.1 meter. The next one, a sort of assignment for you all. Now a body of mass 25 grams, which is 25 into 10 power minus 3 kg, executes simple harmonic motion represented by the equation y equals 0.2 sine 50 pi t. Calculate the maximum speed, total energy, and potential energy when displacement is half of the amplitude. So now he says y is 0.2 sine 0.2 sine 50 pi t. First, again I compare with y equals a sine omega t. As usual, on comparison, amplitude is 0.2 meter, omega is 50 pi. Just comparison here. Now I want maximum velocity. So Vmax is A times omega 0.2 into 50 pi. So 0.2 into 50 pi will be 10 pi. So many meter per second. Maximum energy. This is half m v square max. Kindly substitute. Mass is 25 grams. Now this is v square max here. And finally, potential energy half m omega square y square. So where y is half of the amplitude. So with this substitutions, so as you can see, it is just comparing with the standard equation. I have arrived at the solutions. Next class, I'll work out few more problems from this chapter. Until then, practice the problems. Have a nice time. Thank you.